Just
Oh, we're now live.
yeah, we're live. Hey everyone, thanks for joining us here at Flutter Philippines September Meetup. And this month we will be joined by Jay. He's from Netherlands, and he's a and Dart GD from Netherlands. And Z will be doing the introduction of
Yeah.
Jay.
So, excuse me. So, Jay is a Dutch freelance full stack app developer, administrator, and moderator for the Flutter Community organization, and the host of the live programming show GenericTyping. So, with 2 years of experience writing Flutter apps, he has contributed to multiple open source projects and given talks about various facets of the Flutter ecosystem. In his free time, he likes to experiment with new and exciting technologies such as TypeScript apps and Flutter for web. So yeah, that's Jay.
Hi, everyone.
And
Wow.
probably Jay, you could I'll give you the stage so that you'll be able to introduce
Cool.
yourself as well if you want to.
Yeah, perfect.
Right?
Okay. Well, thanks for the very kind introduction. Hi, everyone. I'm Jay, as the rest so generously mentioned. And today I wanted to talk about unidirectional data flow and sort of what it can do for you as far as state management goes. And we'll get into a whole bunch of detail in a little bit, but first a little bit of my introduction. So I'm Jay, as people said, and so I mainly do software development with a company called Very Good Ventures, who are in New York in the US. Aside from that, I also do freelance jobs a lot and some open source stuff with the Flutter community, with the GitHub and Medium articles that we do there. And I do speaking, like tada. So let's get into it. State management is a very divisive topic within the Flutter world, I'd say, especially in the Flutter community. There's a lot of approaches, a lot of ways to do state management, a lot of opinions on what's best and how to scale it and everything, how to test it properly. And so I wanted to first give a little, like a small introduction to my view of state management within the Flutter world. So first off, using built-in solutions is totally fine as long as your app is small and the scope is not that big yet. Just use built-in solutions like value notifier, change notifier, or inherited widgets, stuff like that. Those will work absolutely fine as long as your app is like small or not that complex. Like a calculator app, I wouldn't write that using Block or MobX or whatever. Just use something built in, and if that works for you, that's perfect. Using that, you can keep state local and just pass it around, right? So if you have one widget with that stateful with some state, you need to pass it around, just do it. As long as that is okay and it doesn't become unwieldy at some point, just use that. But at some point, a lot of apps will have this tipping point where the complexity becomes so large or the scope grows in such a way that you want to properly be able to manage your state within an app, maybe globally or per feature or per screen even. And that sort of becomes a problem if you don't have a right approach to it. Now, what the right approach is debatable, and it depends on the project and the needs and whatever. But most people will agree that you need some sort of state management design pattern in order to make your app scale properly. So that's sort of the goal of what I'm trying to talk about today with unidirectional data flow. Now, unidirectional data flow to me, and it's a really, it depends on the context that you're in and the framework that you're using and in what way you're saying it. But to me, in the context of Flutter state management, unidirectional data flow rather, is a design pattern for state management that allows for four core concepts to me. One is that it's structured, which means that it's properly built and architected in a way that it's gonna work and that it's stable. Another is that it's consistent, so that it's easily people can onboard easily and know, like, okay, I know how to build one part of an app, then it's just the exact same for the other part of the app, right? That it's consistent throughout the app on any skill. Three is predictable. So I like if state management is predictable in a way that you don't have to think about it anymore, but you can just sort of do it. And in that way, that makes it a lot easier to work with and usually better built in general. Then, and lastly, testable, because I think tests, I mean, depends on your opinion about it, or when you write them, or if you write them at all. If you have a proper state management library that includes great testing solutions, then I think that you're going to be way better off. Then again, this depends on your implementation too. You can make an app using Block or MobX or Redux or whatever, and make it the most untestable thing ever if you want to. But these frameworks usually make it easy for you to get started with testing and to actually do them. And I think one even more important bit of that is that you want to be able to separate whatever it is that you do in your view with your data from actually the business logic, and whatever you want to do with that data. So how you view it and what you do with it should be separated. In that way, you can, it solves a whole bunch of problems and makes your life much easier and pleasant to work with, not to mention. Now, what I like about unidirectional data flow frameworks within Flutter especially is the way that it works with declarative programming. And I'll get to an example about that in a little bit. Let's take an example first. So I'm just gonna make a sort of visual example of what you can expect from a regular from the counter example, actually. So if you make a new Flutter project using Flutter Create, you're gonna get a counter app, and that has a little bit of state management already there, right? It's this app with a counter in the middle, and you can press a button to increment it. I think we all seen this. So let's take that project from a high level sort of architecture perspective, right? So all the way at the top, you have your material app. That's your My App widget in this case, and it's the app that actually it's the widget that renders the material app. Then from there, you render a home page, right? In this case, it's a stateful widget, and it contains a counter, which is an integer. Now that counter can be incremented using a button at the bottom right, the floating action button. And once you press that, an onPressed method gets called. Now, that onPressed method will then increment the counter, but that change won't show up on the screen yet, right? There's a method you need to call or something you need to do in order to tell Flutter that that widget needs to be updated. And usually with an audience, I'd ask everybody, what is that method? But yeah, since we're here, it's setState, right? So calling setState will execute whatever function is inside it, and then trigger a rebuild on the widget that you called it in, right? So now we have this sort of nice loop: onPressed, increment the counter, set the state, trigger a rebuild. Let's look at a little bit of code about this. So here's the default sort of template. I've changed nothing about this. This is just the default what you get when you make a new Flutter project. Here's the app, the top level widget, and then we get the actual homepage, which is not really that interesting at this point. What's important is the state, where we actually build the widget, and these are the important bits, right? So we have the counter itself, which is an integer. Then in the increment counter function, we call setState and increment counter to update the screen. And then we pass that increment counter function on to onPressed to the button callback. So that's the default example, right? Now I'm going to take it a little bit further. So let's take this entire functionality that we have here and put it into the function that it's actually called, increment counter. Put that in there. Great. Now, your boss comes along and says, hey, yeah, great work on the counter. Very unique and super helpful. Could we have a second screen where we also show that counter and we can increment it too? And then you're like, well, okay, that's not a problem. I'm going to move the times. So yeah, let's make it. So you add a second page. And in this case, it also needs to increment and counter. So you could make it a stateful widget, right? And in that case, we can just pass along those both the counter and the function to increment it, right? And we can do that with just a little piece of code. Just pass those two arguments along, and then at the other end, we can use them and render them just like in the homepage, right? And this is no problem. If this is your scope, if this is what you do, you can be a little fancy about it. Maybe use an inherited widget or some sort of builder type or stream or whatever. But the base example here is that we have this link between the homepage and the second page where we pass over the counter and increment counter. So this is all fine. And then your boss comes along again and he's like, hey, great work on the second page. Extremely unique. Yeah, we got to move with the times, and tab navigation is the hype now. So we need a tab navigation, which means that we can switch between views with the tab bar at the bottom. So this is interesting because it creates two navigation stacks, right? Or for every tab you have, you create a new navigation stack that you need to keep track of. But that's no problem. I mean, as long as these pages are connected, then our link will still work. Oops. Yeah. So this is interesting because now, since we can navigate from to the homepage or the second page from the same base widget, right? The My App, our link no longer works. So we can throw that right out. So what's the naive solution here? Well, let's see. The most common widget that needs those counters and increment counter methods is My App. It's the one above both pages. So in this case, the naive solution would be to lift that state up, put that counter and increment counter in the My App widget where it doesn't belong because it has nothing to do there. And then now we can make these hard links and pass them along just like that. And our counter app works, but is extremely ugly this way. There's a lot of code duplication and you have to pass it along. And if you add one thing, then the entire thing breaks, right? And this is just, I mean, this is 2 pages and an app widget, right? Imagine if you have a bunch of pages, which most apps do. I hope I've demonstrated sort of the problem here. And of course, there are ways to improve this sort of structure, and it's very tiny, but it demonstrates a problem that a lot of apps will run into at some point. So I want to show you sort of an approach to fix this using unidirectional data flow. So using unidirectional data flow to me means 3 main things. 1, somewhere you have an immutable state. This is a class or an integer or a string or whatever you need. Most of the times it's going to be a class. Now, this class is immutable for a reason, and we'll get into that in a little bit. And it represents either your entire app or a part of your app or a single screen or a certain feature, whatever you want, right? So you have that state, you have that object. Then you have a collection of events that represent actions, right? So these are intents for something to happen. This is a way to convey an action. And we call these actions events, right? So we can have a state like a counter and an event called increment counter, right? And that event can just be a class or an enumerator or whatever you want, but it's an object, something. Then, third, we have a reducer or just a pure function that takes that state and an event and produces a new state. So this is going to be a function that will just take, that receives a state and an event, doesn't matter what, and then produces a new state, not edits the old one, it produces an entirely new one. The reason we cannot edit the old one is because it's immutable. So instead of making or editing that previous state, we instead make a new state every time that the reducer is called, right? So it takes in a state and an event produces a new state. That's the entire point. Now, to sort of illustrate this in a sort of graph form, this is what it's going to look like if you run a sort of architecture like this, state management pattern inside your app. You're going to have your state somewhere, doesn't matter what it is, and then that gets passed to your view. Now, the view, just from its perspective, just gets a state, renders it, and that's it, right? There's no state management going on in the view here. It's just it receives some object and it renders it, right? Then the user taps a button or does whatever, does an action like login or I don't care. Some event happens from the view, then it sends an event to that reducer, right? And the reducer also receives the state. How is depends on the implementation that you use. Usually the reducer lives close to the state, so that way it always has access to it. So state is passed to the view, it renders it. As soon as something happens, it sends the event. Now the reducer has received an event and a state, and what it does is, I just told you, it produces a new state. And now you might start to see this sort of nice cycle pattern going on, right? We have a reducer that produces states. The states are passed to the views, and the views produce events that then get passed to the reducer. So this is a really easy and predictable flow to me, because the only thing that your view needs to do is not manage state, not know how things work. It just needs to know what data do I have now, and what do I need to do when a button is pressed, send the event, right? That's all it needs to care about. And that makes this sort of separation of concerns extremely pleasant to work with and really easy to deal with as sort of a mental model. Now, there are a bunch of state management sort of solutions that implement a pattern like this. First off, I'm going to talk about a couple. First off is Redux. Now, Redux is very popular within the JavaScript community, and as soon as Flutter started getting popular, it was ported over by John Ryan and Brian Egan. They made the packages Redux and Flutter Redux, respectively. And it's been doing great ever since. I mean, there are a lot of people using this, happily so. I've used this in the past too, and then transitioned to some other patterns. But right now, I'm most fan of a pattern called Block. So this is also a package developed by Felix Angelov, one of my colleagues, and and it's sort of like Redux in a way. Sort of the API is similar, but it focuses a lot more on streams and having this sort of live data type thing. And there's a lot of nice things that you can do with logging as well. So I really like it. And then lastly, we have Qubit, which is actually lives really close to Block, and it's very similar. It's just the way that it's implemented is a little bit differently. The API is a little bit different, but most of this is all very similar. Now, I first wanted to talk about Block. So Block stands for business logic component, and this is one of those state management patterns that use unidirectional data flow a lot. So what is a block? It's really small and simple, actually, from an API perspective. A block is nothing more than a class that has a state and a bunch of reducers, right? So a bunch of functions. It's just a class with some state, a mutable state, and a bunch of reducers that can take an event and a state and produce a new one. Now, this block in particular uses the streams API, which means that blocks can be used as streams, which has some really nice effects for, or some really nice gains as far as writing UI for it goes. Because now, right, we have stream builders that allow you to take in a stream, and every time the value changes, you rebuild your UI. And you don't need to worry about subscribing and then unsubscribing to the stream and keeping subscriptions ready and canceling them and then, you know, all this async stuff. You just write the stream builder, and then every time the stream produces something, you get your build method is called, right? So you produce a new widget, and the same works for block. There's a block builder where you can tell it, hey, I have a block here. As soon as its state is updated, then rebuild my widget, and that's it. That it can be as easy as that, and that makes declarative programming really nice. Then, block specifically manages and produces new states internally, which means that if you have a block, if you create a new block or instantiate one, then it manages and produces new states internally, which means that UI components don't have access to block to tell it to produce something or do something. The only thing that the UI can do is send events over to the block, and the block itself that you write decides what to do with the state and the event that it receives. And then it can emit or produce new states, right? So block specifically consumes events in the form of classes instead of, you can have, like in Redux, for example, you can have events as enums or whatever you want, integers, doesn't matter. In block, you use classes. So for each event that you want to convey, you use a class. So like counter incremented could be a class, or counter plus button tapped, whatever. That could be a class. And then you send that over to the block, and it does some stuff, and then whatever you want it to do, actually, and then you can emit a new state depending on that action. Let's take a look at a small example of how you would make a new block. So first off, import the package. You don't need to use a package for block or any state management pattern for that matter, but I like this block package because it has some really nice functionality that I'd like to leverage. It has some great internal logic that's going on that I wouldn't want to write myself. I'll just leave that up to the block package. And then to make a block, that's super simple too. In this case, I'm making a counter block, and that extends block, right? Then first off, it wants the type of the event that it's gonna take in. In this case, it's gonna be a counter event, which is just another class that I can then extend from and send events through. And we have the counter state, and that is just a class with a counter, an integer inside it. So that's all really needed to make a counter block like that. And that's, I'd say that's the easy part, but it doesn't get much more complex. So as far as complexity goes, though, the way that I like to use a block is sort of per feature or per screen. So you can structure these however you want. You don't want your blocks to get too big, though, because then they get really unwieldy. It's nice to split up blocks. So what I usually do is per screen that I have, if it has some state or it needs to fetch some data, and it's not just like dumb UI, it actually does something. In that case, I'll make a block for it separately. And then, I can have a block. I can have a widget inside that also has a block, right? You can nest these as far as you want, and it won't become more complex because the blocks individually don't know about each other. Right? It's all really scoped, which makes it perfect for testing as well. So you need some way to have a block at some point in your widget tree, right? And you probably want to retrieve that block in some way as well. And if you're thinking, I can do that with global variables, then don't, because there are way better ways to do this. So to me, the most convenient and most testable way of passing these blocks around, so making a new block and accessing it from somewhere else, to me, is using block providers. And so block providers come from the Flutter block package, which is a separate package that has widgets and optimizations and convenience methods, all for using blocks or qubits within Flutter. And so block provider is one of those widgets that allows you to provide a block from some point in the widget tree all the way down. So if you provide a counter block here, and you have a widget somewhere down below your widget tree, you can access that block provider. That's what it does, or that block rather. So let's look at an example of how you would, like a high-level architecture example of how you would implement a block structure like this. So at the top, we have our material app again. And then right next to it, or very close to it, you could have a block provider that creates a counter block. Now, that block provider will create it and then make sure that anything that needs it further down the widget tree or to the right in this example can access that counter block just by requesting it. Then you can have a whole bunch of widgets in between, right? Maybe you start out with a scaffold or some sort of stack, and then perhaps an app bar and the body column with a bunch of widgets. And then at some point, you want to access your counter block. You can do that using blockprovider.of and requesting that counter block. But as I told you before, one of the widgets that I like a lot is Block Builder, because Block Builder allows you to give it a type that it needs to look up. So in this case, it will look up, hey, what's the closest counter block that I can find in the widget tree? Then it will find that block provider. And then every time that block counter block's internal state changes, your Block Builder will rebuild. So a new state comes in, the block builder will rebuild the UI that's inside it, or the child that it returns. So the block builder is now dependent on that block provider, and then we can have any other widgets that we want below that, right? But we know that anytime that like counter block is so that counter inside it is incremented, that change will come through, the block builder will rebuild the widget inside it, and now your UI is updated. All without using stateful widgets. It's all stateless. We're going to see that in a little bit. So Qubit, I really like Qubit. It's sort of, I think it's my favorite pattern at this point. It's very similar to Block. It's sort of a smaller and simpler form of Block. In fact, all blocks are actually qubits. Usually they, or in the past, they lived separately, but now they live in the same package because blocks are actually sort of fancier or bigger versions of qubits. So they come in the same package. It's all in the block package. Flutter block comes with qubits. So they live very close to each other. Now, qubits are actually, they're basically the same concept, but it's a different way of how they execute it. Right, so the API is a little bit different, but it's still very nice to work with. In fact, I'd say that it's nicer to work with, and the main reason for that being because it uses public methods instead of classes to convey actions or events. So as I told you before, in Block, if you have some sort of event that you want to trigger, you can just make a class for it and then give your block an instance of that class and any data that it might need. But if you have like really small bits of UI, it's way easier to just make a method on the qubit and just call that. So in block, it's an anti-pattern to actually call an event on a block or to explicitly call something on a block. You always need to do events, always push events. And with qubits, it's totally fine. It's expected that you just use public methods instead. So that makes it a lot smaller and a lot easier to work with. But block has pluses too. Block has a lot of is a lot nicer to work with if you're going to do anything regarding logging the events that come in and go out. And you can do that with Qubit too, but it's a lot more manual work instead. So I like Qubit. And so that's why I wanted to sort of take the next, I guess, 20 minutes and go through an example project, a counter, but we're going to qubit it up and we're going to provide some state management, some proper state management. So that's what I'd like to do with you now. Let me just set up the project here. I'm going to run that on my machine. And now let me open up chat. There we are. Hey all. Oh yeah, please send questions if you have them. I'd love to answer them afterwards. I know that the quality might not be that good on most of these. So I am going to restart this and then enlarge the font for y'all. And let me know if it looks good or if it needs to be bigger. Anything's fine. Sorry, preparation didn't catch the best of me. Okay, there we go. How's that? Is that okay? I think that's good. Cool. Let's run with it. Sick. Okay, so it's running the app now. It's going to start up any minute. I'm just going to take you through what I have right now. So this entire project, the complete example and all the slides and everything is up on the link at the end of the talk. So please have a look if you want. But for now, let's go through it. So here is the top level app, right? I'm running that. It's a material app with some theme data, whatever, it's all the default. And then we render some sort of homepage, right? And that homepage is right here. Now that homepage is stateless. The original Flutter counter example has a homepage that is stateful. We're going to do it stateless. That homepage has a scaffold with an app bar and a piece of text at the app bar, fine. Then it has a column that's centered to its children. And then we have two pieces of text. One that tells us how many times we've pushed the button, and then the actual counter, or at least that's where this should show up. Then at the other end, we have the floating action button, which lives at the bottom right. Yeah. And that floating action button has an onPressed method that can be called. And as soon as it is, that method will be executed. So here we go. So this is our app visually. Now, nothing happens yet because everything's stateless and we haven't implemented any qubits or whatever. But we're going to change that. So I am going to add a counter qubit to this example, and then we're going to implement it and make a simple counter. And it's going to be really fast and easy. So first off, I can write that qubit manually, right? And there's nothing wrong in doing that, but I like to not write boilerplate if I can avoid it. So using the block extension that ships with or that's available for Visual Studio Code and for IntelliJ and Android Studio, I'm going to right-click on lib here and say create new qubit. Now I can name it something. I'm going to call it counter. And so here we have a counter qubit, and it's extremely small, right? And that's also what I like about it. The fact that you can convey sort of complex state in such an easy way. That's nice to me. So here we have a class, counter qubit, and extends qubit and then gives us the state. There's no event here, right? Usually we'd have an event.dart file here as well, but qubits don't use events, not like that. You can just call methods on the qubit. So that's the counter qubit. now I'm going to go to the counter state, and what this is so this is the state of our counter block, and it's going to be immutable. And it has a couple things going on here. First off, it has an abstract class for the counter state, and then an implementation of that counter state. We're not going to need this for now, so I'm just going to remove that, and now this is going to be our actual state. So it extends equatable, and equatable is a package that I use a lot, even without blocks or qubits, just in like models. It's really useful to have equatable. What it does is whatever props you put in the props property, it will use that to see if one class is equal to another. Right? In Dart, usually if you do a class instance that equals another class instance, you will get it won't check if whatever is inside it is equal. Rather, it will check if the memory addresses aren't the same. And you don't usually want that. We want to be sure that one counter state can be equal to another counter state. And we can write our own operator equals, override, and hash code and whatever. I'm not going to bother. I'm just going to use equatable because it's way easier. So what does our counter state have? Well, first off, it has an integer, the counter. Then we need to be able to assign that integer when we construct a new counter state object. So this counter, and so that's all great. And now I'm going to add it to the props so that our props are aware that, hey, if we have two counter states, check if they're equal by checking their counter instead of memory addresses and all that. So that's all good. So I'm going to head back to the qubit, and now this is going to complain because it doesn't exist anymore. So what we can do here in the super call, when we construct a new counter qubit, is we can give an initial state. So I'm just going to say const counter qubit, or counter state rather. And our starting value is going to be 0. That makes sense to me, right? And that's it as far as state management setup goes. We have one more thing we need to do in here. I'm going to make a method that doesn't return anything, and it's going to be called increment. And I'm just going to leave it empty for now. So now that we have that, I'm going to go back to my main. And here, let's put some logic in. So nothing moves yet. That makes sense. Okay. So our home page needs access to a counter qubit somewhere, right? So, and again, a qubit and block all live in the same package, Flutter block and block respectively. So I can use qubits when I've imported the block package. So I'm going to use qubits, and we need to be able to provide that counter qubits to other widgets in our widget tree. So I'm going to do that using a shortcut again, and you can either write them yourself or just use the shortcut, and that's going to be a block provider. So this has two parts. One is the child that it's going to render, what is going to be below it in the widget tree, and then whatever qubit or block it needs to construct. So in this case, it's going to construct for us a counter qubit, and let's import that. And the block provider is not const, but our homepage can be const. You can ignore that const for now if that's too complex, or if you don't understand it, just ignore it. Just think we now have a block provider that makes a counter qubit. So any widget below the block provider, like homepage and anything below it, now have access to this counter qubit instance, right? So now we've made a way to provide that qubit to any widget in the widget tree. The only thing we need to do now is actually render it and send the actions over. So over here with the ellipses, I am going to add a block builder, and that block builder will look up any qubit or block that I give it. In this case, it's going to find the counter qubit that I make right up here, right? So it's going to find that, then it's going to subscribe to it and give us the state. So now, starting from line 51, I have access to our counter qubit state, and I didn't even have to write anything with subscriptions or whatever. So it's just like a stream builder in that way. So this block builder says, hey, give me a block builder that rebuilds my widget every time the state of a counter qubit changes, of the nearest counter qubit. And we also have to provide the type for that state. So starting from line 51, I have access to my counter qubit. So I am going to use some nice string interpolation and say state.counter. So now my piece of text will display the counter that's inside the state by looking up the counter qubit. And every time that state changes, my widget will be rebuilt. Save that, reload, and 0. That's perfect. That's exactly what we expect, right? Because the initial value that we gave our counter qubit is a state with counter 0. So that's perfect. Now, the only thing we need to do is be able to increment this. So I'm going to go over here and to the callback of the floating action button. And then I'm going to say, get me the block provider of counter qubit. And there we go. And then call increment. Oh, we need to give it the context, of course. Oops. There we go. So that floating action button will now, when it's pressed, look up the block provider of type counter qubit that's nearest in the context, and then call the increment function on it. Now, this is a great way of doing this, but there is a shorter way, and I like, keeping my code short and concise. So I'm going to replace this with an extension method that is provided by the Flutter block package, and that is context.block counter. It's a little bit shorter, but I think it reads nicer, right? You have the context, you look up a block or qubit in that context of type counter qubit, and then I call increment on it. So save that, reload, and nothing happens yet. And that makes sense. Well, not nothing. This increment function is actually called, right? But we just don't see it yet. So this is where we're going to need to write the logic to increment our counter. So that's going to have a couple steps. First off, our old counter is going to be our current counter. So that's state.counter. This block has access to that state locally. Then the new counter is going to be the old counter plus 1, right? Because we want to increment it. Now we have our new counter. We just need to create a new state, right? Our new state is going to be a new counter state with our new counter inside of it, right? So that would be 1 in this case if we press it. And then we need to emit that new state, right? I talked about streams before. Because qubits and blocks are basically streams, and because you want this unidirectional data flow, we want our view to get a new state back by asking something, right? The only thing the view needs to do is it gets a state and it dispatches actions, right? So you should not return a new state from an action. That's not the point. The point is that that action may result in a new state getting passed. So what that means is that we don't give back a new state immediately, rather we emit a new state. And we can do that with the code, with the function emit a new state. So what this will do is it will check if the old and a new state are equal. If they are, it will ignore the call. That's nice for performance optimizations. And then if they're not equal, it's gonna make the counter qubit's state equal to whatever I give it here. So that's its new state, and it's going to update all the block builders that listen to this counter qubit, right? So sort of like a value notifier in a way, or like a stream actually. So we have our old counter, which is just the current counter. We make a new counter, which is the older one plus 1, make a new state, and emit that state. Save, reload. There we go. Our counter works. Perfect. And so this is awesome. I mean, it's a counter, but the fact that it's so short, concise, and easy to deal with, that's what I really like about this pattern. Now I can't help myself, and I'm going to make this a one-liner because this is just state.counter plus 1. So we emit a new state with the current state's counter plus 1. It's a bit shorter, so it's a bit nicer to work with. There we go. Still works. And so one last nice thing that I wanted to talk about with sort of this pattern and how Qubit and Block especially handle this kind of data flow is that because we're using emit, you might have already guessed that we can emit as many times as we want, right? We're not restricted to emitting once, If I want to, I can emit this multiple times. This won't do anything, but it's not really useful. But we could if we wanted to. For example, say that you have some sort of loading state. You can first emit that loading state, right? And so now your UI will get an update, and it will be told that, hey, we're now loading. And so the UI will show a spinner or some sort of text or whatever. And then you're gonna, asynchronously perhaps fetch your data or do a complicated instruction. So you can await that. And then once you have that data, you can emit again and say loaded state, and then give it the data that you retrieved, right? So doing asynchronous UI updates with state management is really easy this way, because you just emit loading, then you do whatever you need to do, and then you emit your data. And then you're done. And then your UI will react accordingly. The only thing you have to do in your UI is tell it, hey, am I in a loading state? Render this. If I'm in a error state, render this. If I have some data, render this. And you don't need to worry about, okay, but when do I need to call set state and update it? And, oh, but what if one part of my UI doesn't know about that update yet? Then I need to call set state on that too. So I need to pass it. None of that. Just emit new states. That's all there is to it. All right, so that's really all I have to say about qubits and block and all that good stuff. All this code is up on, and the slides, including a PDF version of the slides, are all up on cut.ly/JFK Talks. Yeah, you can find me on there too. It's actually my GitHub, so yeah, hit me up on there. My Twitter is @JFKDev, as you might have seen already, and I'd love to answer any questions you might still have, or hit me up on Twitter or send me an email or whatever. Yeah, I hope it helped you, and I'd love to hear from you again. Thanks, everyone. Oh, 1 second.
Hey, thank you. It was a nice talk. Joshua, are you there?
Hey, I'm there.
Hey Jay, thanks for the talk. I'm sorry I got disconnected for a few minutes. So yeah, pretty much these are the questions that we have received from the community. So probably we'll start with the first one.
Sure.
All right. Okay, so I'll read it for you. When should I start caring for the unidirectional flow of my data in my Flutter app? So probably he's asking what, when, in terms of scale, when do you think is the right time you should care for adding unidirectional data flow?
Yeah, I think that's the right approach to the question. Well, the moment, I mean, one solution is always use qubits, and that way you'll be safe. Obviously, there's a lot more to architecture and system, like technical architecture of an app than just its state management solution. It's also the question, how are you going to implement APIs and repositories and caching and save data, all that. But in general, that's sort of, I would say that's sort of a feeling. If it's more than a couple screens, I'll probably use qubits. But knowing myself, I'll probably use qubits if I have one screen anyway, because it's just so much nicer to work with. So yeah, right from the start. And it doesn't need to be unidirectional data flow, but all I'm saying is that it really helps in a lot of ways that it almost doesn't make sense to me not to use a framework like Block or Redux to see. So I'd say right from the start or something.
All right. Guess we'll proceed with the next one. Is qubit or block can be referenced inside another qubit or block, or is it an anti-pattern? What can you recommend in this case? And if I want to trigger some event to, yeah, I think that's the only question to the other.
Right. So it's you're absolutely right. It's an anti-pattern. I'm not sure if it's officially an anti-pattern. It probably is, but I never pass one block to another, because then you are so tightly coupled between them that it makes testing and especially following how your data flows extremely complicated. So you never reference a qubit or a block inside another. What you can do is there are two main answers to this question. One is if it has anything to do with some other piece of data that you need to retrieve from your block. So if some data is dependent on by more than one block or qubit, you probably want to make a repository for it instead, which is just either a singleton or some instance of a class that deals with that data, and then you can listen to that data from 2 blocks or how many other you want, right? And then a good thing is authentication. That's a good example where I have an authentication block that just provides update about authentication, and it listens to an authentication repository. But I can have another block or qubit that also needs to do something with authentication, listens to the same repository. So that's sort of my pattern. Another is if you need to do something with the UI that triggers something on another block. When an event comes in, you can use block listeners, which are just functions that get executed as soon as your block updates. But doing it from the UI makes sense because blocks should be totally separate from each other. So yeah, that's your two answers for it.
All right. Proceed with the next one. What is the difference between using RX Dart, Flutter block, and block for the block architecture pattern? Uh, it's probably this vague question.
Yeah,
But yeah,
I can speak to what's the difference between all of these. Well, first off, block and Flutter block go hand in hand together. The only thing Flutter block does is add widgets that makes dealing with blocks easier in Flutter, but you don't need it, just like you don't need the block package. But I would use them because they're extremely nice to work with. I almost never use RxDart, but there are situations where I find it really convenient to have stuff like behavior subjects and value streams that come from RxDart or combine streams together. Not too much because usually that gets really complicated and hard to follow really fast. But yeah, I think you can use all of them together, honestly.
okay. Uh, Great. Right. So next question, is block gonna support selector pattern or hooks pattern?
I'm not sure. I'd have to ask Felix, but that I don't think it will, but that's for a good reason. Because if you are listening, anything you might want to do with a selector, okay, hooks aren't going to be a thing probably because hooks are just so far fetched. That's almost, to me, that's too far away from what block is doing. It's sort of it clashes a little bit. But a selector pattern where you can, I assume that it's filtering what data you want out of a block so that you only rebuild when that block has that part of the data changed. If that's what you're asking for, you can already do that. If you listen to a block, you can make a selector and only re-render once the data that you actually want gets updated. And if you're using a block builder, you have a parameter called build when, where you can say only if this counter or whatever element from the previous and the current state have changed, only then do I want to rebuild. If anything else has changed, then ignore it. Don't rebuild. So that's your selector if that's what you're asking for.
All right. For the next question, Z.
So, what is the learning curve for these kinds of libraries from a beginner's perspective?
From a beginner's perspective, hard to say, but as long as I think getting down the language would be more of a trouble. I think this is very doable for beginners because the concept is, to me, very easy. It's hard to say because I've been doing Flutter for 2.5 years, but I think as far as a beginner goes, if you understand the flow of I have a view that gets a state and dispatches an action, then I have a state that is immutable, and my qubit or block can emit new events willy-nilly, then I think you've got it down. The only thing you'll have to learn through experience is how are you going to structure that in an app. But there's a lot of awesome resources that I'll put in the chat afterwards. And ask me if you want to. I'll send on Twitter, hit me up, send me a message. I'll send you any resources you want on learning how to structure blocks. But I think it's very doable.
All right. So probably we can start with this one or proceed with the next one. John, maybe I can do this one.
Sure, sure. So the next question is, what's the difference of using provider and block? Doesn't block use provider under the hood?
Good question. Block doesn't use provider. Excuse me. Block doesn't use provider under the hood, but block provider comes from the provider package. So Flutter block, the package, not block itself, but the Flutter block package, has block providers, and they are just fancy providers. The only thing they do is make sure that you provide a block. That's all it is. So what's the difference? Well, they're really two completely separate things, but in fact they go very well together using block providers and block builders. And yes, it uses provider under the hood for that operation, but block itself is totally on its own.
All right. This is an interesting one. Why do you think it's called qubit?
I'm not sure. You know what? And probably it's on Felix's. It's probably on the repository or something. I've read the README and edited it, but I haven't seen the name come up there. I'll ask him. You know, I'll send him a message right now and ask him. And if he gets back to me later, send me a message on Twitter and I'll put it up there.
All right. No worries. Right. Yeah. From our audience, it's a really good topic. Yeah.
Oh, thanks. Oh, that's really sweet.
All right. So probably this is the last one. I use RxDart for implementing block pattern. Is there any reason why I should switch to Flutter block package?
I think depending on what you want to do, they do very separate things. Right? Rx is about manipulating streams and creating new ones, to me. And Flutter block is about easily handling block-related streams in your Flutter UI. So I would say use them both. Flutter block is just widgets and extensions, and RxDart is just, influencing streams and making new ones and stuff. So if
And
that's
maybe
what you want.
All right, and maybe the use of RxDart for the specific block pattern is just concerning the actual architecture of the pattern itself, but not really the ones that, for example, Flutter block provides the widgets or the for Flutter. Yeah,
Exactly. And I would also say that I very rarely use RxDart within the block pattern just because you don't need it that much. You just subscribe what you need to and create a state, and which is your view model. So there's no reason usually to select anything or use the stream manipulators within RxDart because it's all done automatically just by definition of how you use the framework.
all right. This has been a pleasure talking with you, Jay, and having you talk here for our community. I
Likewise.
assume that a lot of people really learn from your talk, and they'll be able to use it for their own projects.
Yeah, I hope so. And again, if there are any questions, please let me know.
All right. Thanks again, Jay, and we probably see you on the next one.
Sure. Yeah, I'd love to. Thanks for having me.
All right.
Thank you.
Bye-bye.
Bye bye.
Bye.